It is stated in the affirmative speech of my opponents that helium-3 is in short supply here on Earth. In order to compensate for that short supply, the U.S. government should increase its development of the Earth's moon for energy, specifically helium-3, which the moon's surface harnesses. That will not be necessary, because we could use renewable energy here on Earth in order to eliminate our short supply. Therefore, the U.S. government should increase its development of automated machines, not to dig up the lunar surface and heat what is collected in order to obtain helium-3, like my opponent states, but to collect resources like sunlight and wind here on Earth, and use that to compensate for our depleting amount of energy. Unlike the big step of launching a shuttle full of equipment and technicians into outer space, we, as U.S. citizens, can take small steps here on Earth, like improving the construction and installation of our homes to create more energy-efficient homes. We can install fluorescent lights in place of incandescent lights, which can also improve the way we use our energy. In addition to energy-efficient appliances, something known as phantom loads can significantly reduce our waste of energy. According to the U.S. Department of Energy, in the average home, 75% of the electricity used to power homes' electronics is consumed while the products are turned off. A report from the University of California, Berkeley says that phantom loads account for about 6% of all national residential electricity consumption. You can eliminate phantom loads by unplugging appliances and electronics when they are not being used, or plugging them into a power strip and turning that strip off whenever they are not in use. As for solar paneling, on October 8, 2015, the calculation that also takes into account that per square meter of solar panels is hit by 1,000 watts of solar energy, the Land Art Generators calculation states that Earth will need 191,817 square miles of solar panels for lighting up the entire planet with renewable power. On the website Tech Insider, in an article written by Rebecca Harrington on September 24, 2015, called "Here's How Much of the World We Would Need to Be Covered in Solar Panels to Power Earth," more power from the sun hits the Earth in a single hour than humanity uses in an entire year. Yet solar only provided 0.39% of the energy used in the U.S. last year. If solar is 20% efficient at turning solar energy into power, we'd only need to cover a land area about the size of Spain to power the entire Earth renewably in 2030. It is also stated in my opponent's speech that not one, but 2 missions were set to take place for the search for ice and/or water on the moon. The Lunar Flashlight, which will be a piece of technology that hovers close to the moon's surface, looking for darker areas that would be considered ice and water, and then the Prospectors mission will be another piece of technology that actually lands on the moon's surface and collects the ice found by the Lunar Flashlight. But this mission will inevitably cost more than it's worth. Today, costing $10,000 to put 1 pound of payload into Earth's orbit, and the Lunar Flashlight weighing about 26 pounds itself, it would cost roughly $260,000 to launch the Lunar Flashlight into space, and that does not include the equipment we would need to build it. The Lunar Prospector, weighing roughly 348 pounds, makes this grand mission almost $400 million. The U.S. debt, estimated to be $16.3 trillion in the third quarter of 2012, won't allow for this mission. It would make more sense to simply conserve water here on Earth by making smarter choices about how we're using our water. These choices are obvious, like fixing leaks, turning off the tap when washing our hands and brushing our teeth, and going to the car wash to get our cars washed as opposed to washing them ourselves, because car washes recycle the water. Not relating to my opponent's speech directly, but some concerning questions that came to mind include: how will taking away from the moon affect Earth? And what will violating the space treaty do specifically for the U.S.? Taking patches from the lunar surface, like my opponent stated, in order to collect helium-3 significantly takes away from the moon's all-around diameter. We rely on the moon for currents and tides in our ocean. It is said if the moon's mass decreased, it would end up closer to Earth. According to an article titled "What If the Moon Orbited the Same Height as the ISS" by Phil Plait on the website Slate.com on May 19, 2014, if we bring the moon in really close, suddenly one side of the Earth is a lot closer to the moon than the other. The Earth's near side is 2,158 kilometers from the moon's center, and the far side is nearly 15,000 kilometers away. That's a huge difference, and the tides felt by the Earth would be amplified enormously, nearly 100,000 times what we experience now. There would be global floods, as high kilometer tidal waves swept around the world every 90 minutes due to the moon's closer, faster orbit, wiping everything in its path clean. The Earth itself would also be stretched up and down, so there would be apocalyptic earthquakes, not to mention huge internal heating on the Earth and subsequent volcanism. If we did start harvesting the moon for energy and water, we would inevitably be violating the Space Treaty. In the Outer Space Treaty's text, enforced October 10, 1967 in Article 1, it states that the exploration and use of outer space, including the moon and other celestial bodies, shall be carried out for the benefit and in the interest of all countries. So, in order to explore the moon for water and energy, we would need to convince those other countries who signed the Space Treaty that it would inevitably be helping us and them. We would probably do so by agreeing to give them what we uncovered to other countries in equal parts, and we would be basically doing all the work. In a more recent case, and to sum it all up, the space mining legislation signed into law by President Barack Obama on Wednesday, November 25, 2015, gives U.S. space firms the right to own and sell natural resources mined from asteroids and other space bodies. It's considered to be dangerous and potentially illegal by some experts. Dr. Odenton of the University of Kent states that space mining could potentially damage the environment surrounding Earth and eventually result in resource-centered conflict. So, in conclusion, the U.S. increasing its development of the Earth's moon for energy, like helium-3 and water, would have more disadvantages than advantages.